Hello everyone, let's solve today's Leetcode Daily Challenge question. So the question is combination sum 2. Given a collection of candidates and a target number target. Okay, so find all unique combinations in candidates where the candidate number sum to target. Okay, so each number in candidate may only be used once in a combination. Okay. Note the solutions that must not contain duplicate combination. Okay, so if we see this example, we have candidates arrays 10, 1, 2, 7, 6, 1, 5, and the target is 8. Okay, so we can see the output 1 plus 1 plus 6 is 8, 1 plus 2 plus 5 is 8, 1 plus 7 is 8, 2 plus 6 is 8. So we have to return these combinations, and this combination should not be duplicate. That means you can see here we have two ones, so using this one we can have 1 plus 2 plus 1 plus 2 plus 5, and using the another one also we can get 1 plus 2 plus 5. Okay, but we have to uh, we don't have to consider the duplicate. Okay, so here how we can solve this question is we can make use of recursion. Okay, so um, if you have solved the question of subarray sum, so even there also we have to find the subarray sum, like for this subarray sum, if that sum should be equal to this target or something like. Okay, so there also we will we have used, or even permutations combinations question also. Okay, so similarly here we have to use. So first thing is we must not contain duplicate combinations. Okay, for that we what we can do is let's sort this array, and if we get, let's say after sorting, what will be this array? It will be 1 1 2 5 6 7 and 10. Okay, so using 1, okay, using 1 we can have 1 2 5, and then also we can use this one, we'll get 1 to 5. But how we will avoid this is we will check if there are adjacent or just consecutive numbers, same numbers. Then for this number we will get our output. Okay, let's say 1 to 5. But for this one we will ignore this case. What we will check, if we will check if the previous element has its same as it is. Okay, so we will ignore this case. Okay, so how we will solve is first take our answer, list of list, answer is equal to new. Okay, now uh, let's run. Okay, we have to return this answer. So before that we will call our recursion function. Let's say recur. Here what we have to pass this answer. We need current linked list. Okay, or array list, whatever you prefer. We need a list, either it is linked list or array list. So um, for for the current combination, to store the current combination, we'll need a current list. So we'll pass a list, let's say new array list. Okay, so this will be current list. Then we have to pass this candidate array into target also. Okay, so not like this. We will pass candidates and target also. Okay, and we have to pass the index. Initially, it will be 0. Okay, so let's write our method public void. It is not returning anything. It will be just add each combination to our answer. So picker. So first we have this linked list. Then we also need one list, that is list of integer, that will be our current. Then we need this both in candidates and target. So instead of target we can say this as a remaining, because what we were going to do is from target we are subtracting our current element, whatever we are considering. Okay, and comma, this is int index. Okay, now what will be the base condition? Base condition is remaining remaining equal to 0, then what we have to add? We have to add answer current to our answer. Answer dot add new array list here current. Okay, now we have added. If let's say if there will be some case, right, where our remaining will be negative, so you can see the number 10. If I subtract 10 from 8, we'll get a negative. So this combination is not possible, so we'll return nothing. Remaining, if it is less than 0, then we will just return. Okay, then okay, now we have to check for all combination. So here we have to sort the array, right? Arrays dot sort candidates. Now here I'll use a for loop for int I is equal to from our index I less than candidates dot length I plus plus. Now here, what we will check, we already have seen for this case, duplicate case. What we will see is if our I is greater than index. Okay, so I is greater than index and not the current one. Okay, we are not considering the current one because, okay, let's see, if we have this, um, that means whatever index we are passing that, and candidates of I is equal to candidate of I minus 1. If both are equal, then we will continue. Okay, now now else, now else what we want to do else, no need, I guess. Else we can just, okay, here let's say else if take and this keep in else. So okay, so if any condition doesn't satisfy that, we if we don't get our array, then only we will continue with this. Okay, so yeah, then here we have to add the current element in our current linked list. Okay, so current dot add what our candidate rates of I. Now we will call our recursion for recur. Okay, so we will pass our answer, comma, then our current list, then candidate. Okay, for remaining, what we will be doing is, okay, remaining minus current candidate, remaining minus candidate of I, comma, then this is what we got our remaining sum. So 8 minus 1, we'll get 7, we'll pass 7 and we'll check with 7. Okay, so again, comma, what is it? Index. So we'll pass I plus 1. Okay, so now for this recursive call we have included this one, let's say. Okay, that is our candidates array from ith index. So we have to remove also. So what we will do, we will remove current dot remove the last element which we have inserted. Okay, so every time whatever we are because we are not always taking new current list. Okay, so whatever we are adding after that recursive call, after it is returning, we have to remove that also. Okay, so current, is it a current? Yeah, current dot, it is size minus 1. Okay, so what we have done is first we took linked list. Okay, list of list. Then we have sorted our candidate array. Then we have called this method public void recur, where we are passing our list of list, that is this answer. Then we are passing one list, that is current. Okay, then we have candidate array. Then we have our target, that is here we will consider as a remaining. Here we have variable target, that is why we are passing. Then we need a index. Okay, so at the end, after this all recursion, the our all this combination list will be added to the current list. Okay, and this will be returning. Here we will check if our remaining is 0, that means we got our answer, we got our combination, so we'll add that in our answer. Okay, then else if the remaining is negative, then we will simply return, because we this combination is not possible. Okay, so then we will starting from I, from our index till till the length, and we are checking here we are checking with the duplicates, and we are adding hmm, our ith index, ith element, and also removing it, and calling this recursion answer current candidate remaining minus candidates of I and I plus 1. Let's run. Okay, okay, where we have, okay, here to twice new list, or is there any error? Okay, so here we need linked list, right? Because list is just like a parent, and these are child, linked list and array list. Okay, so you can see our test cases are passed. Let's submit. So using this recursion solution, we can also call this as a backtracking. Okay, so you can solve this question, and we have to sort it, because to handle the duplicates. Okay, because you can see here 116 is okay, but for this one and for the next one, we don't have to consider the same target, right? It is, so it is taking some time to submit. You can watch my playlist Leetcode Daily Challenge, where you will able to find daily questions which I'm solving from last few days, and will be solving for next days also. So you can check that, and let's wait. Yeah, maybe there is an issue with internet. Let's refresh the page. Yeah, let's submit. Yeah. Now you can see our solution got accepted. So if you feel this video is helpful to you, and then please like this video and subscribe my channel. Stay updated. Thank you so much for watching.